This is Physics 2, Lab 4 by Aaron Christian. The purpose of this lab was to examine how the magnetic field of a bar magnet changes with distance. Our goal is to compare the observed magnetic field to the predicted values for both on-axis and off-axis positions. To make these predictions, we will use VPython for calculations and visualizations. Some assumptions we made during this lab was that there would be no other magnetic fields interacting with the phone besides the bar magnet and the Earth. And we assume that the bar magnet acts as a magnetic dipole, that the magnetometer is perfectly aligned with the Earth's north and south axis, the magnetic field falls off as distance increases, and we know the magnetometer chip is in the phone. On this slide we have the results, and we will explain how we found these results later in the presentation. Here are some fundamental principles that we use to make our calculations. So we have the Biot-Savart law. The law describes that the magnetic field generated by a steady electric current is generated by a steady electric current, stating that the field at a point is proportional to the current element and inversely proportional to the square of the distance from the element. On the right, we have what the law is drawn out. The magnetic field of a dipole is our next principle. The magnetic field of a dipole is the field produced by a magnetic pole, such as a small current loop or a bar magnet, characterized by a strong field near the dipole and a weaker inverse cube dependence on distance in the far field regions. On the right, once again, we have our formulas. And then the last principle is the distance dependence formula. This formula is for a magnetic field, describes how the field strength decreases with distance, typically following an inverse square law for a long straight current and an inverse cube law for a magnetic dipole in the far field. And once again on the right we have the formulas. On this slide we have the experiment procedures. So as you can see on the right is kind of a visualized example, and we would adjust the phone's orientation so that the magnetometer is perpendicular to the Earth's magnetic field. And then we would identify the exact location of the magnetometer with chip within the phone, measure the distance between the magnetometer from both on-axis and off-axis positions. Here's a graph for our on-axis experiment, and we have all the numbers and the graph to support it. Using the principles we found to use in the earlier slides, we use these to calculate all of our answers. On this slide, we have the results from the on-axis and off-axis measurements. So we have the perpendicular and by Earth. The Earth stays the same simply because we aren't changing the location of the phone or the Earth, obviously. And the perpendicular changes because the magnet is being placed in different locations. On this side, we have the possible sources of errors. Other magnetic fields being present can cause inaccurate readings. The exact location of the magnetometer. So we gave a general area of where it was, but it could be off within that general area. Errors when measuring visually can cause inaccurate readings. Accidentally bumping the phone when we're changing the location of the magnet, and failing to perfectly line up north in the beginning of when we're setting up the phone. For our what if question, we have what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field. How would your results have changed? If the meter stick were placed at an intermediate angle, the Earth's magnetic field would interact with the bar's magnetic field unevenly, leading to inconsistent measurements. This misalignment could distort the observed field strength and direction, making it harder to accurately analyze the magnet's behavior. The next what if questions is, if we were to stick two identical magnets together end to end and run the experiment again, how would you expect your measurements to differ? With two identical magnets placed end to end, the total magnetic field strength would increase, resulting in stronger readings at all measured points. However, since the magnets are aligned in the same direction, the overall field orientation would remain unchanged.